Hello students, I hope that you are good, well and fine. In today's session, we will be seeing about vector product of two vectors or cross product of two vectors. So far we have seen about the dot product, which is the other name. It goes by scalar product. Why? Because the output will be the scalar. Here you will have cross product, the output will be your vector form or your component in your component form. Okay. So we have discussed the three-dimensional right-handed circular coordinate system. Yes. In this system, when the positive x-axis is rotated counterclockwise, counter means, I hope that you know what do we mean by counterclockwise. Okay. Into the positive x-axis, sorry, y-axis, a right-handed, a screw would advance in the direction of positive z-axis. As you can see this diagram, that what is happening here, you are moving your positive x axis into the direction of your positive y axis in counterclockwise, means anti-clockwise. Okay, so counterclockwise is just simple anti. Counter means opposition of something. Counter means, okay, so counter means opposite. Opposite clockwise means the usual way of the minute hand, the second hand, the hour hand of clock moves in this direction. You say that direction as clockwise direction. The counter of it will be anti-clockwise direction or counterclockwise. Okay, so counterclockwise direction will be this. So x, as you can see this thing. Now, if you do this movement, the counterclockwise from x positive to y positive, your screw would advance in the direction of positive z-axis. This means it will go up in the positive direction. Okay. Now, in a right-handed coordinate system, as you can see, this is your right hand. Yes, you can place your hand here parallelly. So your thumb represent your positive z-axis. Okay. Clear? And when the fingers are curled in the direction away from the x-axis, you can see, you are having your right hand. Okay. When you are trying to curl your finger, this means you are taking your fingers away from the x-axis but closer to the positive y-axis. Yes? Okay. Clear? So this is also represent your what? Right-handed coordinate system. Okay. So I hope that it is clear. Okay. Now keep this point in mind. Now, as this is very, very useful from the perspective of vector product or cross product. Okay. Clear. Now let's see definition for vector product. That if you have two non-zero vectors A and B, first of all, the notation for cross product will be A vector cross product with B vector, the cross symbol here, the times symbol, and defined as A times B, okay, or A cross B is equals to product of magnitude of AB times sine theta n cap. Sine theta multiplied with n cap. Okay, so what is happening here? So where theta is the angle between, obviously the theta will be the angle between A and B vector, where we have taken this theta from 0 to pi. Now, what is happening? That the n cap will be what? A unit vector which is perpendicular to both. So this n vector must be, first of all, the unit vector, a unit vector. and must be perpendicular to both vectors A and B. Okay, this is very important. Vector A or vector B is 0, then theta cannot be defined here. But we define our cross product equals to 0. When either A or B is 0, then cross product we have defined as it equals to 0. Okay, as we just, if you remember from the scalar product thing, we have seen the same such pattern there, that either if one of the given vector is 0, then their dot product we have also defined as 0. Now some observation that the output will be your vector. Yes, your A and B, two vectors, both of them must be non-zero. Then the cross product is equals to 0 if and only if that both of your vectors are parallel to each other or collinear. Okay, clear? Okay, now in particular, if you try to see that if a vector is going to be cross multiply with itself, you will have 0 vector as your output. Why? Because A and A itself making your parallel angle or 0 angle. Okay, so 0 angle in between A itself. Okay, the same thing goes for minus A also. So A cross multiply with minus A, you will have 0 vector. Clear? As theta is your 0, and in second, as theta is your pi. Now, if theta is pi by 2, this means cross product of AB will be the just magnitude of A and B. Okay. In view of observation, the above two observations 2 and 3 for mutually perpendicular vectors. Okay, for mutually perpendicular vectors, we have what? We have I cross I, J cross J and K cross K. As you know, these pairs form 0 angle. This means 0. But here IJ forms 90-degree angle, JK forms 90-degree angle, KI forms 90-degree angle. You will have K hat, I hat and J hat respectively. Okay, in a specific order. That what order it is following? That IJ, then you will get your output as K vector. KJ, as you can see, cross product with JK, then you will get your I. KI, cross product of KI, you will get J. So this order is okay. So I hope that it is clear. Okay. Now fifth observation. In terms of vector product, the angle between two vectors AB, in terms of cross product we are talking about, you will have sine theta is equals to cross product of AB divided by this will be what your magnitude of A and magnitude of B. Clear? So your sine theta will be what? The magnitude of A cross B divided by magnitude of A, magnitude of B. Okay. Cross product I will be minus K. Okay. KJ cross product will be minus I and IK cross product will be minus J. Okay. The same thing we are applying. Okay. What we just saw in sixth observation. Now eighth. If vector A and B represent the adjacent side of a triangle, then its area given by half of cross product modulus of cross product of AB. Okay. So let's see. So by definition of the area of a triangle, we have from this figure, you have half of the base is AB times CD. AB times height. Half into base into height. Height is CD. Okay. Now AB is just what? If you try to find out it is just the magnitude of B vector. Yes. And CD, this CD will be just nothing but you can find this magnitude CD. Yes, this CD vector or DC, whatever you want to say, will be just magnitude of A, this magnitude multiply with sine theta. Okay, magnitude of A, this magnitude multiply with sine theta. Okay, now the area will be what? Half of magnitude of A multiply magnitude of A sine theta, and this is just nothing but the magnitude of A cross B vector. and half of it. Clear? So the area of triangle you can directly find out by using the cross product. Okay, clear? Now ninth, if given vector A and B represent the adjacent side of a parallelogram, then its area is given by this absolute value or the magnitude of A cross B vector. Okay, from this figure you can see the area of parallelogram is what? What will be your area of this parallelogram? Is AB times DE. Yes. Now AB is your vector B, sorry, a magnitude of vector B. DE will be your magnitude of A multiplied with sine theta. Clear? How we are getting this? I hope that it is quite simple. What we are using is sine theta is equal to perpendicular by hypotenuse thing. That's it. Now area of parallelogram, just replace your things. So AB is just magnitude of B and D is just magnitude of A sine theta. So you will have this, and this is the another way to represent this expression, or this thing is magnitude of A cross B vector. Okay, clear? Now we state two important properties of vector, which is distributive property over addition and scalar multiple property. Okay, as you can see, if A is going to be cross product with B plus C, this gives the same answer as if you do A cross B plus A cross C. And in this case, you will have lambda can go with A, okay, and also can go with B, and you can still find the cross product without any further change in your final result. Okay. Now how to find your cross product? Very easy. When you have your component form as for A vector as this and for B vector as this, then their cross product may be given by as the determinant of the first row will be I hat, J hat, K hat. The second row will be A1, A2, A3, the components for A vector. And now the third row will be the components for B vector. Just find this determinant, you will get your cross product. Okay, I hope it is clear. Okay, now we have already seen this, so please do remember from property 1, these are very important things. Okay, clear? Okay, now let's see some example. So magnitude of A cross B, you have to find if A and B vectors are already given to you. So very easy. First row will be I hat, J hat, K hat. Second row will be rows of the second row will be the components from A vector, which is 2, 1, 3, and third will be the components from B vector 3, 5, minus 2. Now find the determinant. Determinant will be I times minus 2 minus 15 minus J times minus 4 minus 9 plus K times 10 minus 3. As you can see, if you simplify, you will have your A cross B vector as minus 17 I hat plus 13 J hat plus 7 K hat. And the magnitude will be the root of 17 square plus 13 square plus 7 square, which will give you root of 507. Next example, find a unit vector perpendicular to each of the vectors. The two vectors are given to us, vector A plus vector B and vector A minus vector B. Okay, you have to find a unit vector perpendicular to both of these vectors. So you have to find vectors such that perpendicular to both of the given vectors. So in order to find the perpendicularity, you have to do what? Okay, so you have to do what? First of all, find the cross product, and cross product will give you what? Cross product will give you the output as which is the perpendicular to both of the vectors. As we have already defined that the cross product, the output or the result of vectors, the cross product of the given vectors will be the perpendicular to the given vector. Okay, so first of all, a plus b will be this vector and a minus b will be this vector. This gives you what? That cross product between this and this, these two vectors, the cross product, whatever the cross product you will get. So as you can see, you are getting this as your cross product. This will be the resultant, the output of your cross product will be the perpendicular vector to both of the given two vectors which you have used to find your cross product. Okay, clear? So this will be perpendicular to this, and this vector will also going to be perpendicular to this. Okay, I hope it is clear to you. Okay, so you have your cross product now, but the question was to find a unit vector which is perpendicular. So it is your vector. Now divided by its magnitude, you will get your unit vector. So unit vector will be this. So this is your perpendicular vector to these two given vectors. Okay. Note that there are two perpendicular directions to any plane. Thus, another unit vector perpendicular to this will be what? Just very simple. Just multiply with minus sign. You will get your another way. another vector. Okay, which is perpendicular but opposite to this vector. Okay. Now next example. Find the area of a triangle having the points as its vertices. So you have your triangle vertices. Okay, this means you can easily find your vectors ABC vector. From that you can easily find your area. How? The half times of magnitude of cross product between AB and AC. Okay. Okay. Now keep this point in mind that the vectors we are taking have same initial point as AB and AC. Okay, keep this point in mind. Now cross product will be this. Find that this determinant you will get minus 4i hat plus 2j hat minus k hat. You will have now magnitude will be root 21. Okay, so your required area will be root 21 divided by 2 square units. Clear? Now next example, find the area of a parallelogram. You have to find the area whose adjacent sides are given by the vectors, these vectors A and B. Now the area is just quite simple. Just find the cross product and then find the magnitude. You will get your area of the given parallelogram. So cross product will be, as you can see, A cross B, A vector cross B vector is equals to, first row will be I hat, J hat, K hat. Second row will be the components, scalars from the scalar component from the A vector, which are 3, 1, 4. Now scalar components from B vector are 1, minus 1, 3. Sorry, 1, minus 1, 1. So 1, minus 1, 1. Now find the determinant. Determinant you all already know how to find the determinant. Determinant will be I times 1 plus 4, which means 5i hat. Now minus j times 3 minus 4, this means plus j hat. K times minus 3 minus 1, this means minus 4 k hat. You will have 5 I hat plus j hat minus 4 k hat as your A cross B. Now what you have to do? Find the magnitude. So magnitude will be very simple. The root of first scalar component, root of first scalar component square, root of square of first scalar component plus square of second scalar component plus square of third scalar component. So you will have what? Root 25, root 1 plus root 16 is equals to root 42. Okay, what you have done is just first of all find the square of the corresponding scalars and then put root over them. After adding, put root over them, you will get your magnitude, and hence this will be your required area, which is root 42 square units. So for now, this is it from the perspective of examples. Okay, so in today's session we will be stopping here. Okay, in the next upcoming session we will be seeing exercise related to this concept, vector product or cross product. Okay, which is exercise 10.4. Okay, so thank you all. We will be back, okay, with more concepts, more examples, so that you will able to distinguish, or you will able to solve questions from this chapter very easily. Okay, so I hope that you understood in today's session what we have tried to teach you. So thank you once again. Thank you.